Welcome to the deep dive. Today, we're jumping into something really fascinating and honestly pretty critical: cloud seeding, specifically where it stands in 2025.
Right.
Our goal here is to unpack how it's evolving so quickly, why different countries are investing heavily, and, the complex questions this all brings up.
Exactly. And just to be clear, cloud seeding at its core, it's basically introducing tiny particles, we call them nuclei, into clouds that already have moisture.
Okay.
The idea is to make them precipitate more, being silver iodide, iodized salt, even dry ice. They kind of help coax out more rain or snow.
So just helping things along, basically.
Precisely. But, and this is really crucial, it enhances clouds that are already there.
Yeah.
It absolutely cannot, create a storm out of a clear blue sky.
Gotcha. And it feels like this isn't just a fringe science anymore. It's becoming, well, almost a mainstream tool for dealing with climate change impacts.
Definitely. Things like water scarcity, longer droughts, even tackling air pollution. These are pushing cloud seeding forward as a serious climate adaptation strategy. The stakes are just really high now.
So, okay, the why now seems clear. But what about the scale? Are we talking small experiments, or is this like a major global thing?
Oh, it's global. And some programs are massive. China, for example, has the world's biggest program. They're aiming to cover huge areas.
How huge?
We're talking over 5.5 million square kilometers. They use planes, rockets, and interestingly, a lot of AI to manage it, mostly for drought and air pollution.
Yeah. Wow. Anyone else going that big?
Well, the UAE is very active, over 300 missions a year, which is vital for them, getting only about 100 millimeters of rain annually. They're big innovators, too, using AI-driven drones.
Drones, interesting. What about closer to home in the U.S.?
Yep, several western states have programs. Utah's is actually the nation's largest. Their snowpack, boosted by seeding, apparently provides 90% of their water.
90%.
Yeah. And Colorado is aiming for maybe a 15% snowfall increase. That could mean about 80,000 acre-feet more water a year for the Colorado River Basin, enough for maybe 160,000 homes.
That's significant. Any other examples?
India is also getting serious. They're launching a national artificial rain project. Delhi specifically is trying an experiment this month, July 2025, hoping it helps with their severe air pollution.
Okay, so the scale is undeniable. What about the tech itself? You mentioned drones, AI. What's really driving this push now?
Good question. The delivery methods are definitely getting smarter. Drones are becoming more common, like in the UAE. And there are tests, like North American weather consultants trying direct silver iodide dispersal from drones, plus more remote-controlled ground generators.
So less reliance on just planes.
Sort of, yeah.
Yeah.
But the real game changer is probably the precision. AI is huge here. Better weather forecasting using networked radars, satellite maps. It all helps optimize the when and where to seed.
Making it less guesswork.
Exactly. More data-driven. Yeah. And there's a sustainability angle, too, a shift towards solar-powered ground generators. Each one can save like 15 metric tons of carbon emissions a year compared to older methods.
That's good to hear. But okay, let's get to the bottom line. Does it actually work effectively? We hear these percentages, but you also said it's imprecise.
Right. That's the million-dollar question, isn't it? Proponents will point to studies suggesting, 5 to 15% increases in rain or snow. There was that big project, SNOE. It showed, and I quote, visual proof of seeding. They managed to generate enough snow in 2 hours to fill almost 300 Olympic pools.
Wow. Okay.
And Delhi's hoping for maybe 60–70% success with their pollution experiment. It's also shown results for hail suppression, potentially reducing damage by 25 to 75%.
But there's always a but, isn't there?
There is. The scientific community stresses, again, it only works on the right kind of existing clouds. It's still hard to definitively prove how much extra precipitation is from seeding versus what would happen naturally. It's complex. And no, it doesn't cause massive floods or giant storms, despite what some might claim.
Okay, so effectiveness is debated. What about other issues? Controversies?
Oh, absolutely. There are definite environmental and health questions. Long-term effects of silver iodide in soil or water, for instance. Proponents argue it's largely insoluble, but the concern is there.
And disrupting weather patterns.
That too. Could seeding in one area mean less rain downwind? It's a possibility being studied. Plus, potential health risks from prolonged exposure, though usually concentrations are very low.
And then there's the whole policy mess, right?
Exactly. In the U.S., it's all over the place. Florida actually made weather modification a felony, while Montana allows it, and Texas has conflicting laws. It's fragmented.
And internationally.
There's really no overarching international governance, which raises geopolitical questions, who owns the clouds? And public perception is tricky. often fueled by misinformation. Think about those Texas floods in July 2025. Lots of conspiracy theories popped up blaming cloud seeding, even though the science didn't support it.
So it's powerful, potentially useful, but comes with a lot of baggage.
That sums it up pretty well. Cloud seeding in 2025 is definitely complex. It's evolving fast. It offers real potential for climate adaptation, but we absolutely need to tackle the scientific uncertainties, figure out clear rules internationally, and build public trust through transparency.
It really makes you think. Considering everything we've discussed, the potential benefits, the risks, the unknowns, and the sheer urgency of climate change, what responsibility do we have, maybe individually, maybe globally, to understand this technology and perhaps even manage our own atmosphere? What part of this deep dive stands out most to you? Thanks for joining us for another deep dive.